right, we're going to start our next unit with descriptive data basics. And so we're going to first talk about certain types of data. And those two types of data that we're going to first discuss are categorical and quantitative. Okay? So this categorical data is actually what we're going to start with first in this unit. And this is items that can be labels, like word labels. You can even have numbers that are used as labels, such as zip codes. So maybe colors or zip codes. But what happens is these items will end up turning into collectively a proportion of the total. Okay? So if you say the proportion of Aledo High School students who live with zip code 76008, okay, that kind of thing. It does not make sense to find the average of those items. All right? And then one other thing that's really interesting about this categorical data is that in science, you may be familiar with it as qualitative data because it has qualities, certain qualities to it. All right, so now let's take a look at quantitative data. So these are definitely those numeric values where it makes sense to average them, such as time or miles per hour, that kind of thing. All right. So the next thing that we want to do is we're going to focus first in this chapter on categorical data. And so we're going to first look at the different ways that you can display this categorical data. And so frequency tables is one of those ways. And so you can see here we have a table to display those frequencies. And so I want to point out to you that we have either frequencies, we also have relative frequencies. And so this relative frequency means that we have counts that are relative to a total, okay? So our frequency are the counts. For example, when you did your bear hunt lab at the beginning of the year, you took tallies of the frequency of how many of each color you saw. And then we can't compare frequencies because when you went out there and you did your bear hunt lab, everybody did different amounts, saw different amounts of bears. So what we then did do is we came in and we turned those into percentages so that it made sense for us when we were comparing those items. So, for example, if we were looking at the proportion of blue M&Ms you saw out there, if you saw, a total of 55 M&Ms out there, and I remember we did not search for the blue ones, but if we had, that would have been 13 out of 55. That's relative to the total, which is your 0.236, and so then that of course would be your 23.6%. Okay? All right, so you can see that we've got these two bar charts down here. I want you to notice that bar charts have got spaces in between each of the bars, okay? And so the reasons that we have spaces in between each of these bars is because it is categorical. I could display these bars in any order. They do not have to be blue, red, orange, green, yellow, and so on. They could be switched around. Okay, now let's take a look at the type of data in this first graph compared to the second. This first one would be considered just the frequencies because it is just the counts of those items. And this one, even though it says frequency here, we know that because I see that these are in terms of percentages, that these are actually our relative frequencies. They are relative to the total number of M&Ms. All right, so now let's go to the top of the next page, and we see this segmented bar chart. It is also commonly referred to as a stacked bar chart, okay? Again, we see we've got these spaces in between each section because this is categorical data. I could have put those in any order that I wanted to. Of course, it made sense to be in terms of quarters 1, 2, 3, and 4. Okay? I can also tell that these are not relative, because if they were relative, then we would have had like the total, a bar that would be the total percent of each of the quarters. So we would have then seen proportionate to the quarter what these totals were. So therefore I can see that we don't have that, that this was actually a frequency chart. All right. So next thing that we want to talk about is this issue of violating the area principle. So that is something that you've really got to watch out for, because when you violate the area principle, you'll find that you can create a picture that is not proportionate to the total as it should be. And so if it is not proportionate to the total as it should be, then you are misrepresenting this data visually. Okay? So you can even have it such that incorrect conclusions are drawn because of the misproportionality of the pictures. So if we take a look at these first two pictures here, we have this on the left, this very nice looking three-dimensional drawing, and these are the classifications on the Titanic and the proportion of people who I guess made up the Titanic. Okay, so if we were taking a look at this, we could see on the left, if you want to see which looks like the smallest, to me it looks like first class looks like to be the smallest classification of people on the Titanic, and to me it looks like that the third class is the largest. Okay? But if we take a look next to it, over here on the right-hand side, we have the actual numbers written out, and so then you can see that that is not the case. First class is not the smallest. In fact, second class is the smallest, and we can see that third class is not the largest, where in fact crew is the one that is the largest. So because of the tilt and the three-dimensional layout that this was chosen for this picture on the left, it misrepresented both the smallest and the largest of those items. All right. Now, I had a question today. Why would anybody want to do that? Well, I'm going to show you some actual news articles here in a second of where journalists misrepresented the data, and whether that's for a particular reason, because they're trying to kind of exaggerate a point or not, or if they're just clueless and not paying attention to what's going on. But I'm trying to educate you so that you can see those things and know that that happens and know better. All right. So let's talk about three things that you could say are wrong with this picture here. Okay, I think the first one that students typically tell me is that the 50% does not look like half. Okay, and then another one, okay, because this is the graph that has to do with usage of substances in teens, and we have 26.7% marijuana use, 31.5% heavy drinking, and then 50% use alcohol. Okay, so I'm thinking that we've got this problem here with heavy drinking and alcohol, okay, because heavy drinking is actually a subset, so there should be, there's overlap of some sort, is a subset of alcohol use. Okay, so something's going on there, because this should be contained within that alcohol use somehow. Okay? And then finally, if you total up all of those amounts, they total more than 100%. Because you can see, with the pie chart, we're going to expect it to total up to 100% of what we have. All right, so I have here some there are 5 pictures here, 4 of which are from actual um, publications or news articles. They were on TV and such. I want to start at this bottom right-hand side with the 2012 presidential run because we just looked at pie charts. So what do you have to say about this pie chart right here? Okay. I mean, first of all, the 63, maybe even the 60%. Okay, so we're definitely violating the area principle. The 70% looks the smallest. Okay. Furthermore, I don't even know what this is about. How do we have so many percentages? I mean, are we talking 63% of the group or something? I don't know. Okay, but whoever on Fox News was that came up with this particular format for this type of data is not, is clueless of what's going on here. Okay, let's go to this next one. This is also another Fox News graph here, a chart. So what we have is a demonstration of what's going to happen if Bush tax cuts expire. So here I can see currently right now we've got this 35%. I don't know exactly what that means, but 35% I guess have the top tax rate, it looks like. Okay? Now, what I want you to notice is that they're saying in January 1st of 2013, if the Bush tax cuts expire, this on the right-hand side is the proportion of people who are going to be experiencing the top tax rate. Okay? So I'm just so confused because this in my mind looks like that the tax rate has quadrupled in size. The area principle made it look like it has quadrupled, when in fact it's just gone from 35% to 39.6%. So it's just gone up 4.6%. It has not gone up 400%. Okay, and you can see, that they're putting these different scales on the side, 34% to 42%, to have that misrepresentation. All right, here's another one. This was not in a publication, but this is just another example that we're talking about the percent who agreed with the court. Well, it looks like Democrats overwhelmingly, in fact, 3 times as much Democrats than the Republicans and independents. 3 times the size. Okay? But if you take a look at what's going over here on the left-hand side, it is indeed not 300% more. It is only, from here to here, is 8% more than the Republicans or the independents. Okay? So misrepresentation. Here we are also having the violation of this area principle because this is demonstrating what's happened from quarter 1 of 2009 to the second quarter in 2011. So a little over 2 years, it looks like over 100 million people in the U.S. are now receiving some form of federal welfare. Okay, so here's what's the issue. It looks like we're going from this much in 2009, okay, and how much more did we get? Probably 3.5 times more. It increased. It looks like it grew 3.5 times more over that 2-year period, when in fact it just increased from like 97 million to 107 million. So about 10 million, which was, less than 10% increase. Okay? All right, and then here's one final one. This is the rising signs of why does college have to cost so much? So actual article put out in the Ithaca Times about Cornell University. So we can see here in this top graph that we are representing what's happening with the Cornell University. So the cost of Cornell is rising and getting higher. Okay, it's definitely going up. All right, but what's interesting is that we're actually kind of counteracting what we're trying to, the point we're trying to make, because this says Cornell University's ranking. Okay, well, so let's think about what's happening here with this ranking. If, say, here, we're ranked, 15th in the nation or whatever, and here we're ranked, 12th in the nation or whatever, and then down here we're ranked, second in the nation. In reality, what's happening when our ranking is going down? What is actually occurring when our ranking is going down? We are getting better, okay? And costs are increasing, okay? Plus, the scaling on the amount on these is off because they're not even on the same scale system. So just tons of things wrong with this picture. It looks all nice and fancy and there in front of the bell clock tower and all that kind of thing, but many things wrong. All right, so in summary, before we go on to the last thing, there are all these different, here are the different ways for the categorical graphical representations, your two-way tables, which we'll go into in a minute, your pie chart, your bar graph, your segmented or stacked bar graph, and your side-by-side bar graphs. And don't forget to not violate that area principle. All right, and so we will go into the next section and reference two-way tables and their test for independence.